Hi, welcome to Finding the Distance Between a Point and a Line, brought to you by the Web Math Department, and your host, Mr. Walker. Today we're going to talk about the distance between a point and a line, but before we get there, I just want to talk about distance between 2 points as a start. And I'm sure you're all familiar with that statement, the shortest distance between 2 points is a straight line. Well, in mathematics, we're going to shorten that up to the shortest distance between 2 points is a line, because for us, 2 points and a line. This little thing here I would refer to as a curve, so that all lines are straight in mathematics. So, starting there, how can we go about finding the distance between 2 points? Well, you've been through that already. The distance between 2 points is the length of the line segment that connects them. Well, just what we said. There's our line segment. If we know the coordinates of those 2 points, we can use the distance formula to find the length of that line segment. And you know that if this is point 1, then we'll call its coordinates x1, y1, and this other one would be x2, y2, or point 2. And x2 minus x1 gives you this distance here, delta x, and y2 minus y1 gives this distance here, delta y, and we know that in a coordinate system, that gives us a right triangle, and that's how the distance formula was developed using the Pythagorean theorem, as you know. All well and good. But again, we're interested in the distance between a point and a line. Well, how are we going to handle that? Because the situation we've got is a line and some point not on the line, and we want to know how we're going to figure out what the distance between that point and the line is. And I am going to hopefully connect the distance between 2 points to this problem. As a lead into this question, I'm going to first look, let's go ahead and put in some coordinate axes here. And if I place a point out here, let's say it's the point 4, 2, and I asked you what the distance was between that point and the y-axis, well, there's a connection here because the y-axis is actually a line. And if I'm interested in the distance between this point and the y-axis, well, depending upon your definition, I could look at that as being the distance, but if I look at that as being the distance between the point 4, 2 and the y-axis, then that means there's a bunch of them. Because why couldn't I just say, well, it's to here, or it's to here? There's actually, if that's the only definition that we're going to work with, an infinite number of distances between the point 4, 2 and the y-axis. So we need to refine our definition. And what we're interested in is the shortest distance between that point and the y-axis. Well, if I think about this distance here, I'll call it d2 for lack of anything else, I can see that that distance is probably not the shortest distance between the point and the y-axis. And if I go ahead and construct a right triangle here, we know that that distance I've labeled as d2 is a hypotenuse of a right triangle. Thus, it has to be the longest side of that right triangle. Well, if you then take that one step farther to think about, well, if I move this point around, either up or down, does that distance get larger or smaller? Well, hopefully you'll realize that as I move it up, that distance is going to get longer. If I move it down, it's going to start to get shorter. And it's going to get shorter until I get to this point right here. And it can't get any shorter because now I don't have a triangle anymore. and the distance happens to be the length of one of the sides of that right triangle. And then if I keep moving the point farther down, I again create a right triangle where the distance I'm looking at is a hypotenuse. Again, it gets longer. So the shortest distance between the point 4,2 and the y-axis is going to be that line segment that's perpendicular to the y-axis. And how long is it? Well, the answer is right there. It's 4 units long because that's how I got from the y-axis over to that point. Likewise, I could talk about the distance between that point and the x-axis, which, well, by the same argument, would be that distance right there and would have a value of 2. So we're going to redefine or define our distance between a point and a line as being the perpendicular distance, because that's the one that's going to give us the shortest distance. So now, let me relate that to the situation at hand. If we look at our point and our line here, again, I can talk about the same thing, that the distance between that point and that line, if I don't stipulate the shortest distance, could be any one of an infinite number. And until I go in and select, the perpendicular distance, that will be my shortest. Because again, the red dotted lines are hypotenuse of right triangles, and they're always going to be longer than that black dotted line segment between the point and the line. And so the shortest distance between this point and the blue line is going to be that distance I've marked D, the black line segment. Now the question is how we go about finding it, and that'll be the subject of the next tutorial in this series.